Hello students, today we are going to start our new chapter, factors and multiplication. Before starting this chapter, we have to understand the meaning of what are called natural numbers and what are called whole numbers. So I hope you know that what are called natural numbers, but let's revise again. Natural numbers. What are called natural numbers, students? The numbers that starts from 1, 2, 3, 4, dot means up to infinity. Okay, the numbers that starts from 1 are called natural numbers. Okay. Similarly, what are whole numbers? Whole numbers are the numbers that start from 0, 1, 2, 3, 4 and so on are called whole numbers. So we can say that natural number is a part of whole number only, because if we put 0 before the natural number, then it is said as whole number only. Are you clear? So don't confuse between natural number and whole number. Now let's understand what are called factors. What are called factors? Suppose there is a number. Okay, I am saying suppose there is a number that is 24. Suppose 24 is a number. So we know that 24 is equal to 6 into 4. Yes or no? 6 into 4. So here 24 is the product and 6 and 4 are called the factors. What? These are called the factors of 24. Factors of 24. Again I am repeating. For example, okay, 8 into 3 is equal to 24. 8 into 3 is equal to 24. So 24 is called the product. What? 24 is called the product. And 8 and 3 are called the factors. What? Factors. Factors of what? Factors of 24. I am giving you more examples. Suppose there is a number 6. We know that 6 is equal to 2 into 3. So 2 and 3 are called the factors. What? They are called the factors of 6. I hope this little you are understanding. This little you have understood what I have said. This is just the starting. Okay, this is just the starting of factor. Now we'll go to the depth. Okay, now we'll go to the depth. What? Factors of a number. Just here they have said factors of a number. So in factors of a number, there were 12 apples in a basket. Suppose they are given to some children for arranging them in groups, subject to the following condition. Okay, so these conditions we have to follow. We have to follow these conditions before sharing the apples in a group. Clear? So what is the first condition? No apples should be left behind. What? No apples should be left behind. What is the second condition? Each group should have same number of apples. What? Each group should have same number of apples. What is the third condition? Each grouping should be different. What? Each grouping should be different. So no apples should be left behind. No apples should be left behind means, suppose you are distributing 12 apples. Okay, so you have to distribute completely 12 apples. You cannot do like you are distributing 11 apples and you are leaving one. No, you cannot do this also. You cannot do this also, that you are distributing 10 apples in a group and you are leaving 2 apples. No, you cannot do this also. You have to distribute these 12 apples all, and there should be no apples remaining. Okay, hope you understood the meaning of point 1. Now each group should have the same number of apples. What? If you are making 1, 2, 3, 4 groups. Okay, in 4 groups the number of apples should be same. Okay, so look here what I have done. I have done 1, 2, 3, 4. I have made 1, 2, 3, 4. I have made 4 groups. Okay, in 4 groups, see, 3 plus 3 plus 3, 9, 9 plus 3, 12. I have divided 12 apples, 3, 3, 3, 3 each. Means in every group you are seeing that I have distributed equal amount of apples, equal number of apples. Hope I am clear. And each grouping should be different. So let's see what they have done. Look, John arranged 12 apples in 2 groups. He made 2 groups, 1 and 2. In every group we can see that total 6 apples are there. See, in this group, first group 6 apples are there, in second group 6 apples are there. Similarly, Samira what she done, she had made 3 groups. In every group you can see 4 apples. She has distributed it equally, 1 2 3 4, 1 2 3 4, 1 2 3 4. So finally what we are noticing that everyone has distributed the apples in a group, and every group contains the equal number of apples. Look at this, Suraj laid all apples in group 1 of 12. Okay, so he just made one group, but Suraj just made only one group, and in that one group he gave all the 12 apples. And Riddhi, what she has done, Riddhi has given the apples to each and every single person as group. I mean to say, Riddhi has made 12 groups, 1 2 3 4 5 6 7 8 9 10 11 12. Riddhi has made 12 groups. So if 12 apples are there, and if she makes 12 groups, that means what? She has to give one apple in each group. Am I clear? So thus we see that the apples are arranged in the following groups. First group we can see 2 groups are there. See, first 2 groups are there. In every group 6 apples are there. That is why here they have taken 2 into 6 is equal to 12, 3 into 4 is equal to 12, 4 into 3 is equal to 12. So I can clearly say that 2, 3, 4, 6, 1 and 12 are the factors of 12. Again I am repeating. So I can say 2, 3, 4, 6, 1 and 12 are the factors of 12. See, look here what they have said. The numbers 1, 2, 3, 4, 6 and 12 divide the number 12 without any remainder. Okay, just note this particular line, without any remainder. That means I can understand that if I divide a number, suppose if I am dividing 12 with 3. Okay, so if I divide 12 with 3, what I am saying, 3 4 is 12, remainder is 0. What? Remainder is 0. So I can say 3 and 4 is a factor of 12. Clear? And if I divide 12 with 5 5 2 is 10, remainder is 2. So remainder is 2, it is not 0. So I cannot say 5 is a factor of 12. Are you clear? So I can understand the condition that if I have to explain the word factor of a number, that means I have to see that if 6 they are asking that 9 is a factor of 81. Is 9 a factor of 81? Then what I will do? I will just see that is 81 divided by 9 or not. I am seeing that 9 9 is 81 and it's leaving a remainder 0. So I can give a green signal to this particular 9. Why? Because 9 when divided by 81 it is giving a remainder 0, which satisfies the condition that 9 is a factor of 81. Hope I am clear. Now let's move to this particular line. Here see what they are saying. The numbers 1 2 3 4 and 6, the numbers 1, see, if you divide 12 with 1 you will get 12, so it is divisible, remainder is 0. If you divide 12 with 2 you will get a remainder 0. If you divide 12 with 3, the remainder you will get is 0. If you divide 12 with 4, our remainder will be 0, and if you divide 12 with 6, the remainder will become 0. So we are seeing that 12 is completely divisible by all these numbers. Okay, that is the reason these are the factors. So we can say that 1 2 3 4 6 and 12 are the factors of 12. Am I clear to you up to this much? Thus we can say that a number which divides a number without leaving any remainder is called its factor. Okay, hope you are clear up to this much. Then let's move to the next point, that is finding out factors, method of finding out factors. How can we find out factors? Yes or no? So just follow here. we can find the factors of a number by two methods, multiplication and division. What we can find the factors of a number by two methods, multiplication and division. So let's try multiplication first. Here they have given that here they have given an example. The example, let's see here. Here they have given an example. So example is find factors of 24 by multiplication method. So we can express 24 as product of two factors. Yes or no? We can express 24 as product of two factors. How? 1 into 24 becomes 24. 2 into 12 is equal to 24. 3 into 8 is equal to 24. 4 into 6 is equal to 24. But 5 into something is 24? No. 24 is not divided by 5. Clear? 6, yes, 6 is divided, 6 into 4 is equal to 24. 8, yes, 8 into 3 is equal to 24. Thus, we are seeing that the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Am I clear? Again I am repeating. The factors of 24 are 1, okay, 2, 3, 4, 6, 8, 12 and 24. You can also write it like this: 1, 24, 2, 12, 3, 8, 4, 6. You can avoid this particular side because ultimately you are doing the reverse. Means here look here, 4 into 6, 24, 6 into 4, 24. But previously we have learned that the numbers which are dividing 24 are called the factors. So clearly from here I can see if 4 is dividing 24, I can also say 6 is dividing 24 because 6 into 4 is 24 or 4 into 6 is 24, means the same only. Clear? So here given an example, find all the factors of 12. So look at 12. 12 is divided by 1 into 12 is equal to 12, 2 into 6 is equal to 12, 3 into 4 is equal to 12, 4 into 3 is equal to 12, 6 into 2 is equal to 12. Are you seeing this? So from here they have clearly said 1, 2, 3, 4, 6, okay, and 12 itself are called the factors of 12. Am I clear? See, here again the same thing they have done. 1 into 72. So two factors we have got here, 1 and 72. 2 into 36. Again two factors we got, 2 and 36. 3 into 24. Again two factors we got, 3 and 24. 4 into 18. Again two factors we have got, 4 and 18. 6 into 12. We got 6 and 12. 8 into 9. We got 8 and 9. So what are the factors of 72? 1, 2, 3, 4, 6, 8, 6, 8, 9, then comes 12, then comes 18, then comes 24, then comes 36, then comes 72. Just follow here. 1, 2, 3, 4, 6, 8, 9, then comes 12, 18, 24, 36 and 72 itself. So I hope you are clear about multiplication method of finding a factor. Okay? Multiplication method of finding a factor. Now here some examples are given. What? These examples are of finding a factor by division method. So now we are moving into a division method. In division method we are seeing that 30 is divided by 1, then it comes 30. Okay, understood. So leaving a remainder 0. 30 is divided by 2, it becomes 15. 30 is divided by 3, it becomes 10. So ultimately what we can see, that remainder is 0. If remainder is 0, we will say that this is a factor. 1 is a factor, 2 is a factor, 3 is a factor, 5 is a factor. But again, one more thing we have to notice here. Okay, one more thing we have to notice here. Suppose I am dividing here 50. Okay, 50 I am dividing with 5. Am I clear? 50 I am dividing with 5. So 5 tens are 50. Remainder is 0. Am I clear? Remainder is 0. So here what is happening? Here 5 is also called the factor and 10 is also, that is quotient. Quotient is also called the factor. Again I am repeating. See, 5 we are dividing 50 we are dividing with 5. So if it leaves a remainder 0, then this is a factor. And first we have to notice that either this total condition is leaving a remainder 0 or not. If it is leaving a remainder 0, then I can say that 5 is a factor of 50, and the quotient itself will also be called as a factor of 50. Again I am explaining it to you. See, here they are given 30 divided by 1 gives 30. So here what are the factors? What are the factors of 30? The factors of 30 is 30 and 1. 30 divided by 2 is equal to 15. So what are the factors? 2 and 15, because 2 into 15 is equal to 30. So hope you are understanding. Again look here, 30 divided by 3 is equal to 10. So what are the factors? 3 and 10. These are the factors. Again they have said 30 divided by 5. So what are the factors? Is equal to 6. So what are the factors? 5 and 6. Hope you are clear in the division method. Look at this example. Thus the factors of 30 in ascending order. Ascending order means smaller to bigger are 1, 2, 3, 5, 6, 10, 15 and 30. See, 1, 2, 3, 5, 6, 10, 15, 30. Am I clear? 15, 30. Or if you leave this one, see, 1, 2, 3, 5, 6, 10, 15, 30. If you avoid this particular thing, see, if you avoid this much, just look at here, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, see, 1, 30, 30, 2, 15, 3, 10, 5, 6. Am I clear? So you have understood the division method of finding a factor. Now what are the properties of factors? What are the properties of factors? 1 is the smallest factor of every number. Yeah, we can understand that if I am multiplying, suppose, okay, here it is given 1 into 2 is equal to 2. So the factor of 2 is 1 and 2. So 1 is the smallest. Again, if I am finding the factor of 3, 1 into 3 is common. So 1 is the smallest factor in between 1 and 3. If I am finding the factors of 5, 1 into 5, so the smallest is 5. So according to this particular sentence, 1 is the smallest factor of every number. Okay, 1 is the only number which has only one factor. Okay, 1 is the only number. Suppose if you are finding out the factor of 2, so you have to multiply 1 into 2. Am I clear? You have to multiply 1 into 2. But if you find the factor of 1, what you have to do? 1 into 1. So how many factors are there? Only one factor is there. Okay, that is 1 itself. That is the reason here it is said 1 is the only number. 1 is the only number which has only one factor. I hope you are understanding the meaning of this particular line. Then comes the factors of a natural numbers are always smaller than the given or equal to it. What? The factors of a natural number are always smaller. What is the meaning of that? What is the meaning of this? That the factors of a natural number are always smaller than the given number or equal to it. Suppose I am finding the factor. Why I am finding the factor of 6? Why I am finding the factors of 6? So what can I say? 1 is a factor of 6 because 1 into 6. Okay, so 1 and 6 I got. Again, if I have to find 6, 2 into 3. Okay, if any other possibilities, no. So I can find 1, 2, 3 and 6. So are this number 1, 2, 3, 6 greater than 6? No. So the meaning of this sentence is that the factor of a natural number, suppose I am saying here 6 is the natural number. Okay, the factor of this number are always smaller. See, these factors are always smaller than this natural number. Okay, this is only the meaning of this particular sentence. The factors of this natural number are smaller than the given number or equal to it. Hope you are understanding. Observe the following. All the factors of 15 are 1, 3, 5 and 15. The smallest factors of 15 is 1. What? The smallest factor of 15 is 1. Yeah, this is common, that the smallest factor of every number will be 1 and the largest will be the number itself. So the 6, if it is a number, if I have to find the factor, if I have to find the factor of 6, then 1 into 6, 2 into 3. So the largest is the number itself and the smallest is 1. Okay, then all factors of 24, suppose here 24 is a number whose factors are 1, 2, 3, 4, 6, 8, 12 and 24. So similarly all the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. The smallest is 1, the biggest or the largest is 24 itself, the number itself. Am I clear? Now look at point 4. Every number has at least two factors, namely 1 and the number itself. Are you understanding this? See, the factor of 7 has at least 1 into 7. So every number is having at least two factors, that is 1 and the number itself. If the factors of 8 and the number itself, this is common. 1 and the number itself is common for every number. Okay, if I ask you to find the factors of 5, so 1 into 5 is only the possibility. So 1 into 5, so 1 and 5, the number itself, 1 and 5 are the factors of 5. Am I clear to you? Now here they have said checking if the number is a factor of another number. How to check if the number is a factor of another number? Here they have explained 2564 2564 if divided by 4, if it is leaving a remainder 0, okay, then what we can say, 4 is a factor of 2564. I have said you earlier this particular point. I can look at this here, the remainder is 0, that is 4 divides 2564 exactly. So 4 is a factor of 2564. The number 641, that is the quotient, is also called a factor of 2564, but only in such condition in which the remainder will be 0. If the remainder is not 0, then we cannot say that 641 is the factor of 2564. We can only say this, that 641 is the factor of 2564 when the remainder is 0. Okay, when the remainder is 0. Again, let's look at example number 2. Is 8 a factor of 7323? No, because the remainder is not equal to 0. Okay, again I am saying, is 8 a factor of 7323? Look, the remainder is not 0. So 8 does not divide 7323 exactly. 8 is not a factor of 7323. I hope you are clear about the factors of a number. Okay, now we are left around with the exercises. These exercises you have to do by yourself. If any problem is there, please message me. I will be helping you in every possible ways. Thank you. Take care.